Let us now understand one of the concept which we had not dealt so far. The concept of phase of the simple harmonic motion or phase angle. What is phase angle and phase of the simple harmonic motion? Remember, simple harmonic motion always satisfies the equation d square x by dt square plus omega square x is 0. This is nothing but the double derivative of displacement function is equal to minus omega square x, means the double derivative of displacement function is proportional to the displacement itself but in the opposite direction. This arises from, we all know, from the proportionality of force to displacement and the negativity in their directional relation. So, if this is the equation of the displacement of a body, then this has got a periodic function as a solution. The function, periodic function is a sin omega t. It's also harmonic in nature because the relation is sinusoidal. And you see here that if x is equal to a sin omega t, it satisfies this equation, it is a solution, then a sin omega t plus phi will also be a solution to this equation having the same periodicity. So a sin omega t plus phi, if you plug in this equation, it will exactly turn out to be 0 if you differentiate it twice and multiply it by w square. So this is also periodic, having the same periodicity as a sin omega t. What is the periodicity of a sin omega t? Well, you know, if sin t has a periodicity of 2 phi, sin nt has a periodicity of 2 pi by n. In this case, n is nothing but omega. So a simple sin t function has a periodicity of 2 pi if sin omega t function has a periodicity of 2 pi by omega. And therefore, a sin omega t plus phi also has a periodicity of 2 pi by omega, which is the time period where omega is the angular frequency. Now, if x is equal to a sin omega t plus phi is the formula for the displacement function which satisfies the simple harmonic equation, then omega t plus phi is called the phase angle or phase of SHM. Now what is phi then? When t is equal to 0, the phase angle becomes simply phi. So it is called the initial phase. So phi is equal to initial phase or phase at t is equal to 0. If you put t is equal to 0, you will find that this phi is the initial phase of the simple harmonic motion. Now what is the implication? Simply the implication is like this. If x is a sin omega t plus phi, just put at t is equal to 0, x at t is equal to 0 is a sin 0 plus phi, that is equal to a sin phi. Which means at time t is equal to 0, we had been describing that the displacement was 0. But here we are describing the simple harmonic motion that has a particular value of x at t is equal to 0. For example, in this diagram, suppose this is a block attached to a spring, and then it is pulled by some distance. We start with the initial condition x is equal to 0, 2 is equal to 0. But supposing another spring, let's say another mass was moving at a distance x is equal to x1. We want to describe the motion of this which is slightly ahead of this mass. How do you do it? Because for that mass at t is equal to 0, x is not 0, x is equal to x1. In that case, the equation that is to be referred to is this. In fact, x is equal to a sin omega t plus phi is a more generalized solution of simple harmonic motion compared to a sin omega t. So if we plot this, you will find at t is equal to 0, x is equal to a sin phi. So the the simple harmonic curve will look like this. This is t is equal to 0 and this to this length OP is a sin phi. This is a sin phi. So the simple harmonic wave will look something like this. It will be better if you observe this wave and put it observe this SHM cycle over this original cycle. This is the original cycle O, A, B, C, D, and you have given it a positive initial phase, and that is why at 0 there will be an intercept in x which is equal to a sin phi. This portion O to, let's say, Z is a sin phi. Now you notice that this particular shape of SHM, the curve, seems to shift towards the left. This is so, you can find out why it shifts towards the left. If you put at x is equal to 0, what happens? In this equation, if you put x is equal to 0, this becomes a sin omega t plus phi, and you know 0 means sine function is either 0 or 2 pi. So you put a sin omega t plus phi is equal to 0. That will indicate t is equal to minus phi by omega. So this, it is shifted to the left because this is a negative sign, and this amount is phi by omega. This amount is minus phi by omega. Now see this particular shape, the shape of the curve appears to have been shifted to the left. That is, in the time axis it has been shifted to the left, whereas in the x-axis there is now an intercept OZ which is equal to a sin phi. Now if you go on increasing the phase angle and continuously do it, you will find that this shape comes gradually shifting towards the left. It is as if the peak is trying to travel towards the left. Here the peak shift is A to A dash, which is same as this shift, which is same as minus phi by W. Now let us see a visual representation of how the phase angle varies at the SHM curve. When you vary the phase angle gradually on the positive and negative direction and superimpose that same curve on the original curve, what type of motion or what type of illusory motion is observed? Let's see that.